Welcome to the video lecture on image processing laboratory. So in this video you will understand how to write a program to contour an image. Let me consider this image and explain what is a contour. Contour is a continuous line of pixels separating its interior region from the rest of the image. Say for example, you can notice that so many regions are there here like this. Every region has its own boundary. You need to write or extract these pixels. That is what the meaning of contour. Whereas a just boundary of an image is something like extracting complete outer line of this flower. That is the boundary. But finding out boundary of every interior region is what? The contour. You can also call this as a curve joining all the continuous points along the boundary, having some color or intensity in it. And you can also call this as a very useful tool for shape analysis and object detection and recognition. For better accuracy, we have to use this for binary image. Let us move on to the code part. As you all aware that what are the library files to be imported for any program of image processing. You need to import computer vision, and you know why we are importing all this. Matplotlib also you have to import for plotting it. Then NumPy stands for numerical Python for performing any task on the array 2D arrays. So after importing all the necessary libraries, you need to do what is you have to load the image, and you know the procedure for loading an image. Either you can fetch the path and pass that as a parameter to IAMRead function, or else directly you can give a path over here. So after reading the image, the next step is to convert your image into grayscale image. The reason behind this is, as I said earlier, this contour detection well suitable for binary images. So in order to obtain the binary images, first you have to convert the given image into grayscale image, then we have to convert into binary images by using any one of the thresholding techniques. So the first step is to convert the given image into grayscale, and the procedure you already know that using the method called cvt color, you can change the given image into into a grayscale image. The next thing is applying a thresholding. Okay, so as I said earlier, applying a threshold is what? For a grayscale image, that is what my input for this particular function. And after importing this, you need to give a threshold. A threshold value which I am taking here is 127. You can vary these values depending upon your images and see the results. Then this is what my maximum value. This parameter is called a max value, and this is threshold. Thresh is the another parameter, and the third parameter is the type of cv2.threshold, which is the thresholding type that creates a binary image. Okay, so that's what a binary image. So for doing this, what it does is it takes the threshold value. All the pixels which are having lesser than this value will be treated as 0, and all the values pixel values which are higher than this threshold will be assigned by the maximum value. The maximum value which we have taken is 255 because it's a binary image. So for that reason we need to consider 255. So finally you obtained a binary image. Then what we should do is, the actual major function is here. You need to find the contours. For finding out the contours, you need to have a built-in function called find contours. For this, the parameters to be binary image that you have already converted, pass that as a parameter, and the second parameter is mode, the mode is here retrieve external. The meaning dot retrieve external mode will retrieve the only external contours. And the method, one more method parameter is, this is one more method that we are using here to which compresses all the horizontal, vertical and diagonal segments and leaves only their end points, because we need to fetch the contours of that image. And this function returns actually list of all the contours and a hierarchy. So once we obtain all the contours here, next our role is to draw all these contours on the image. So if I try straight away write on the input image, my input image will be changed to contour image. So I don't want that to happen. I don't want to overwrite that. So what I should do is I have to take a copy of this. Then I have to write this contours, all the list of contours which are obtained from this. So for that, the function which we are using is dot draw contour, pass the image, my original image, copy, because I need to fetch the copy of it, then contours, because this is going to give me list of contours to be written on my image. Then third parameter is -1. The reason to use -1 here, we need to draw all the contours here, all contours. Therefore you have to give -1. In case if at all you want to write a contour, a specific contour, like if there are 10 contours obtained, in that 5th contour you have to display, then only 5 you can give. By giving individual values to that parameter, you can draw the contour of specific contour. But here I have to draw all the contours as per my requirement for the program. Use -1 as a parameter. Then followed by the color I have to specify, in which color I have to draw this contour. So you can notice that here 0, 255 and 0. So RGB value that I am specifying. We have made R as 0, B as 0, and I want color to be written in green. That's why I have taken. According to your wish, you can make that R pixel as 255 or B pixel as 255 and make other two values 0, or by giving different combinations you can draw different color also. So color, this is what the meaning of color. Then the last parameter is the thickness that you have to draw. 3 I have chosen here. You can choose 1, 2, 3 and see the difference in the output. After doing all this, this is the final step of algorithm, where it is going to give me the final output with all the contours written on the image. So for that I have to make use of a display function. Finally, display result by using, as usual, I am show, give the title to that, and I don't want grid to be printed on the screen, so axis should be off. Then plot it. Okay, you can notice that this was an image, input image earlier without the contours, and after obtaining the contours you can notice that the green color thickness we have made it as 3, so it's little big. You can also notice that, so here this is what a contour, and you can notice here the contour I have made some corrections in the input, so you can notice that very small tiny contours have detected in this. Okay, in all this you can vary these values by giving 1, 2, 3 and see the output. Okay, you can notice here these are all the contours identified. Okay, I hope you understood the concept. Thank you.